This problem gives us a function for the number of visitors to a website in a given week over a 1-year period. And it's defined over the first year where t is from 1 to 52. So first two parts ask us to define the intervals on which the number of visitors is decreasing and then increasing, and then we're meant to interpret the meaning of the critical point. So to get this done, we're going to need to find the critical point, and we get that by finding the derivative and determining where the derivative equals 0 and or where does it not exist. So let's proceed with finding the derivative. Now this function is two terms. The first term is just a constant 119. Its derivative is 0, so we can ignore the first term here. Proceed to the next term, which is a product. We could either distribute this exponential factor in, or we could just proceed right away with the product rule. I think that's probably the best way to go. So for the product rule, we'll take the derivative of the first factor here. This is a linear factor. Its derivative is just the slope, which in this case is a 1. So I'll put the 1 there just for the sake of the problem. You don't really need to have a factor of 1, but put it in there. So this is the derivative of the first factor, and then we've got just the second factor that we'll rewrite, 0.02t. Then again, to proceed with the product rule, we'll put a plus sign in, and then we'll reverse the order. We'll take the derivative of the second factor here. This is an exponential factor, so with the base e. So to get that derivative, we're going to rewrite the whole thing, e to the 0.02t, and then we'll multiply by the derivative of the exponent, which is 0.02, and I'll put that out front, just so it looks nice. So this is the derivative of the second factor, and then we'll rewrite that first factor, which is the t minus 81. So this here is the derivative, and if we're going to find the critical value, we'll set it to 0, and the best way to get that done is to factor. We have two terms, one term here, two term here. A good place to start with factoring is to look for a common factor, and hopefully we see here there is a common factor in this e to the 0.02t. So we'll factor that out. Pull out that e to the 0.02t. That's going to leave behind a 1 from the first term. And then in the second term, we've got this 0.02 that sticks around. And then we've got this binomial factor in t minus 81. Next up, we can look to simplify by combining like terms. If we were to distribute this 0.02 into this binomial factor, we'd have 0.02t. And then 0.02 times 81 should be, let's see, negative 1.62. We got the 1 out front, so now we can combine the 1 and the negative 1.62. That should give us just a negative 1.62. 1 minus 1.62 is negative 0.62. So the simplified form of the derivative here, factored form, which we can now set to 0, is e to the 0.02t times this 0.02t minus 0.62. And now because it's factored, we can use the zero factor property, which says if your product is 0, then if either of the factors equals 0, you have a solution. This first factor here is just an exponential statement. If you were to look at its graph, it looks something like this. It never actually equals 0. It just gets bigger and bigger and bigger for larger values of t. T could be as negative as you like, but it's never going to actually reach 0. So this factor never becomes 0, which means we're only interested in this factor as a solution. And if you set that second factor to 0, you would add, let's see, 0.62 to the other side, and then you would divide. Here, I'll set it up actually. Right. We're setting this to 0. We'll add the 0.062 to the other side and then divide by that coefficient 0.02. And that should give us, let's see, 31. So t equals 31 is the critical value. We should verify that is in fact on the interval. It is. We're only looking at values of t between 1 and 52. So t equals 31 should be the critical point we're interested in. Now, in order to answer part A and B, we got to figure out what's going on to the left and to the right of that t equals 31. We do it in a couple ways. It might be easiest to just let the calculator evaluate. Another consideration you could use here is that as far as the derivative is concerned, we've already got it factored. This piece here is always some positive number, so the only factor that's going to determine the sign of the derivative is the second factor here. And you'll notice for values of t that are larger than 31, this factor is positive, which means anything larger than 31, we should have a function that is increasing. The derivative is positive. Here's t equals 31. We should have a positive derivative to the right of 31. If we chose a value of t that's smaller than 31, this factor is negative, which would result in a negative derivative. So we'd have a derivative that's going down, or a function that's decreasing to the left of 31. A way you could do that in the calculator is you could plug the derivative in. You could whether you use the factored form or not, the calculator won't care. We'll put the factored form in of the derivative. Matter of fact, let's put both the functions in. Y1, we'll put the 119 plus x, since the calculator uses x as the independent variable, x minus 81, and then e to the 0.02 x. So in y1, I have the original function. And then in y2, I'm going to put that derivative. I'll put the factored form. This is an e to the 0.02 x times, in parentheses, 0.02 x minus 0.62, close parentheses. So now I've got the original function again in y1, the derivative in y2. Assuming I have my table set menu, so to access that, if you haven't done this already, you would click second window. You want your independent variable set to ask. That way, when I go to the table, which is the secondary option above the graph button, if I hit second graph, I can plug in any values I want. Now we care about what's going on to the left of 31, and we should be careful to make sure we're on this interval 1 to 52. So you can really choose any number between 1 and 31. Let's use 20. Y2, which is the derivative, is negative. So that matches what we have over here, right? The derivative is negative, so the function should be going down. If we pick a value that's larger than 31 on this interval here from 1 to 52, we'll use, let's say, positive 40. We have a positive y2. Our derivative is positive here, which corresponds to that upward trend in the function. So we have at t equals 31, since the derivative is 0 here, a relative minimum value. So the function reaches a minimum at 31. So to answer part A, when it says over what interval of time during the 1 year period is the number of visitors decreasing, well, that's just from 1 to our critical point 31. We'll enter it in interval notation, just like that. Right. It's part A. And then, of course, part B is just the right-hand side of this interval. So from 31 onwards up to that 52 is where the function is increasing. Part B. And then for part C, where we're meant to find the critical point and interpret its meaning, well, we know the value of the independent variable t is 31. We could get the output by, since we already have the original function loaded into y1, we can let the calculator evaluate the original function at t equals 31. You can do it by hand, of course, if you want to type it into the home screen. But we're just plugging the value of 31 in for t into the original function. On my table, that's y1. So if I plug in 31, right, no surprise, we got a 0 for the derivative. That's why it was a critical value. But the function itself, the original function, has a output of 26.054. 26.054. That is the number of visitors after 31 weeks. So this is the critical point. I believe the problem asks to round to 3 decimal places, but you could always, in the calculator, you could highlight the output there to get more decimals if needed. This is rounded to 3 decimal places here. So this is the critical point. Again, if we want to interpret its meaning, well, the meaning of this point, again, since the function was going down and then back up over that t equals 31, t corresponding to the number of weeks, we know the function is at a minimum, or in this case, the number of visitors to this website is at a minimum after 31 weeks, and it's approximately 26 visitors, right? If we round this to the nearest whole number, we could say there's a minimum number of visitors after 31 weeks, specifically 26 visitors. And that should be the problem. Hopefully you find that helpful. Thanks. Bye.